everyone, welcome back to Relevel by Unacademy. My name is Lee Suzana and we are going to cover question number 9 to question number 15 in this video. We have covered first 8 questions of time, speed and distance in the first part. Now let's have a discussion on question number 9. A person walks at a speed of 60 km per hour and reaches destination 10 minutes late. If he increases his speed by 10 km per hour, he reaches destination 10 minutes early. Find the distance traveled by the person to reach his destination. Now keep this in mind, guys, that the proportionality concept of time, speed, and distance is a concept which is used in most of the question. And what is that concept? See that we everybody know distance. Everybody know that distance is equal to speed into time. If I keep the value of the distance constant, right? If I keep the value of the distance constant, then speed and time will be inversely proportional of each other. That means if speed goes up, then the time goes down. Right? It's very basic to understand. Let's say that this is your home and this is your office. Every day you're traveling from home to office, right? Let's say that on a particular day you're traveling from home to office at a 10 km per hour. And the time taken to reach from home to office is, let's say, 40 minutes. Now, if I increase the speed to 20 km per hour, now it's very logical that if I double my speed, the time taken would be half of it, right? Time would be 20 minutes, right? So speed ratio and time ratio will be inverse of each other. That means if speed ratio is 1:2, the time ratio is 2:1. That means if you double the speed, the time will become half. Let's say if speed ratio is 1:3, that means if you make your speed 3 times, the time will become 1/3 of the previous time. If speed ratio is 3:4, the time ratio is 4:3. That's a proportionality concept, but this relation this inverse proportionality between speed and time will exist only if the distance traveled at both the speeds is constant. For example, here at a speed of 10 km per hour, you're going from home to office, and at 20 km per hour also, you're going from home to office. So that means the total distance traveled at 10 and 20 is same, right? Now, this concept of proportionality is what we'll be using in most of the upcoming questions, so please understand it properly. Now, let's have a look at question number 9 and use this concept. It says that a person is walking at a speed of 60 km per hour and reaches destination 10 minutes late. So this particular distance that this person is traveling, let's say this distance is represented by this red line. Now, if this distance is traveled at a speed of 60 km per hour, then the person is reaching this destination 10 minutes late, right? If he increases his speed by 10 km per hour, that means if he increases speed by 70 km per hour, then he reaches destination 10 minutes early. See that at a speed of 60 and 70, distance traveled is same. The speed is given to me. First, the speed is 60 km per hour, and then this person is changing the speed to 70 km per hour. The distance traveled, as you can see, is constant. If I say speed ratio, you can see that it's 6:7. So can I say time ratio will be 7:6? That means time ratio of 7:6 means if this person is taking first 7 minutes at 60 km per hour, then the time taken at 70 would be 6 minutes. So there is a gap of 1 minute, you can say that, right? But if you use this information, given the question that first he is getting 10 minutes late, then he is reaching the destination 10 minutes early. So 10 minutes late and 10 minutes early, there's a gap of total 20 minutes, right? Right, a 10 minute late and 10 minute early, there's a gap of 20 minutes. For example, let's say that you're supposed to reach at your office at 9 a.m. On a particular day, if you're reaching 10 minutes late, you will be reaching at 9:10. On a particular day, if you're reaching 10 minutes early, you'll be reaching at 8:50. So difference you can see here is 20 minutes. And this ratio here, you can see the difference is 1 minute. If I want this difference to be 20 minutes, which is 20 times of this value will become 140. And this value will become 120 minutes. Now you can see that at a speed of 60 km per hour, person is taking total 140 minutes to reach the destination. So a speed of 60 km per hour, time taken is 140 minutes. Minute can be converted to hour, right? So total distance, you can see that will be equal to 140 km. Answer is option number B. You could have got the answer by using these two values also. At a speed of 70 km per hour, person is total taking 120 minute. Minute can be converted to hour, right? So in this case also, you will get the total distance traveled is 140 km. Because the distance traveled is same, whether you calculate on this side or on this side, both sides will give you the same answer, and that is option number B. Moving on to question number 10 here. A vehicle traveling at 84 km per hour travels a given distance in 4 hours. How long will it take to reach the same distance if its speed is lowered by 14 km per hour? Now again, you can see that distance traveled is same. A particular distance, right? This is distance. First, the vehicle is traveling this distance at a speed of 84 km per hour. Now, and then how long will it take to reach the same distance if its speed is lowered by 14? That means a new speed is 70 km per hour. So you can see that speed ratio 14 into 6, 14 into 5. Speed ratio is 6 ratio 5. So time ratio would be 5 ratio 6. Now a vehicle is traveling, when it travel at a speed of 84 km per hour, it travels a distance in 4 hours. So in this case, time is given to me as 4 hours. Multiplying factor is 4 by 5. So at a speed of 70 km per hour, time would be 6 into 4 by 5. Right? So time taken would be 6 into 4 by 5. That means 24 by 5 hours, which can be converted into minutes by multiplying it by 60. 12 into 4, 48. Or this would be 288 minutes. That is option number B is the correct answer to the question. Question number 11 here. Two boys began running in the same direction at the same time with a speed of 12 km per hour and 16 km per hour respectively. How long will it take for them to be 12 km apart? So you see that two boys are running on this, right? Both are running in the same direction at a speed of 12 km per hour. Person number A, let's say person A is traveling at a speed of 12. Person B is traveling at a speed of 16 km per hour. Now you can see that in every 1 hour, this person in 1 hour, right? Person B is going to travel a distance of 16 km. And in 1 hour, this person is going to travel a distance of 12 km, right? So in 1 hour, the gap between A and B will be of 4 km. In 1 hour, the gap between A and B will be of 4 km. I want this gap to be 12 km. So time taken would be total B hours. This become 3 times. This will also become 3 times, right? A would be the correct answer. Well, Jerry could run 30 km more if he run at 18 km per hour instead of 15 km per hour. Determine the actual distance it traveled. I can see that the two speeds given, one is 15 km per hour, another is 18 km per hour. Now see that if the person is traveling at a speed of 18 km per hour, the distance traveled is 30 km more as compared to the distance traveled at 15 km per hour. Now you see the distance ratio, the speed ratio here, the speed ratio is given to me. If I calculate the speed ratio between these two speeds given to me is 5 ratio 6. That's a speed ratio, right? That's a speed ratio. Speed ratio is 5 ratio 6, right? If I want, now this is a speed ratio. If I keep the time constant, it's the same concept here. If I keep time constant, time of traveling is constant, right? If you're traveling with a more speed, the distance travel will be more. That means speed ratio is same as the distance ratio. If speed ratio is 5 ratio 6, then the distance ratio will also be 5 ratio 6. That means at a speed of 15 km per hour, you will be traveling 5, then at a speed of 18, you will be traveling a distance of 6. Now this gap is 1 kilometer. I want this gap to be equal to 30 kilometer. So you can see that at a speed of 15, the person will be traveling 150 kilometer. At a speed of 18, the person will be traveling 180 kilometer, right? So the actual distance it traveled, right, as you can see, at a speed of 15 kilometer would be 150 kilometer, right? A would be the correct answer to the question. Moving on to the next question, number 13. A vehicle traveling at 4 by 7 of its maximum speed travels 80 kilometer in 1 hour 30 minutes. What is the vehicle's maximum approximate speed? So guys, here again the speed ratio is given to you. right? If I assume the maximum speed to be 7, then the vehicle is traveling at a 4 by 7 of 7. 4 by 7 of 7 is 4, right? The speed ratio is 7:4. Why I'm assuming 7 here? I'm taking a number which is a multiple of 7 here because this value is given to me in the denominator, right? That's why I'm assuming the maximum speed to be equal to 7. So therefore, assuming maximum speed is 7, the new speed is equal to 4 by 7 of 7, which is speed ratio is 7:4. Now, an 80 kilometer distance is traveled in 1 hour 30 minutes, right? So you see that 80 kilometer distance is travels. This is the distance traveled 80 kilometer. Time is 1 hour 30 minutes. That is 90 minutes, right? Or which can be converted to hours, right? This will be equal to 3 by 2 hours, right? So speed you can see that is 80 upon 3 by 2. That is 160 by 3. Now this speed is made as this speed is 160 by 3. Then we are supposed to find out the maximum speed. It's quite an easy question. You can see that. You can see that. Now you just need to find out the multiplying factor here. The multiplying factor here is 160 upon 12, right? So similarly, the maximum speed is 160 upon 12 of this. Maximum speed is going to be 7 times of 160 by 12. 4 into 3, 4. This is 280 by 3. This is going to be 93.33 kilometer per hour. So we were given a speed, right? When the person is moving at 4 by 7 of its maximum speed, all we need to find out the maximum speed. So value in front of 4 is given. The value in front of 7 is what you are supposed to find out. That's your whole question. B is the correct answer of the question. Looking at question number 14 here, Jason traveled the first 200 kilometer of his journey at 90 kilometer per hour. First 200 kilometer is traveled at 90 kilometer per hour, and due to bad weather, he traveled the next 200 kilometer of his journey at 80 kilometer per hour. What is the approximate speed for the first 400 kilometer of his journey? So basically, we are supposed to find out the average speed here. And the average speed of the person will be total distance traveled upon total time taken. Quite a basic thing to understand. We already have covered a question on average speed, right? So total distance upon total time. Here the total distance is 400 and the total time you can see is for the first 200 kilometer total time taken would be 200 by 90, and for the next 200 kilometer time taken would be 200 by 8. Right, so it would be 20 by 9 plus 20 by 8. That's the total time taken, which you can solve by taking the LCM as 72. This is 160 plus 180, and this would be 340 by 72. And okay, so this is the total time taken. So simply divide the total distance by total time taken to find out the average speed. Right. Now this is 2 into 17. This is 2 into 36. Right. Now this is 1440 upon 17. I just need to divide it. 1440 by 17 is what I need to find out. 17 into 8 would be 136. 40. Sorry, this would be 8. 0. Now this is 17 into 4, 68. 12. So answer would basically be 84.7, right? Answer would be approximately equal to 84.7 kilometer per hour. That's an average speed. Option A is the correct answer of the question. Moving on to question number 15. A cyclist can complete a particular distance 6 hours if he travel at his normal speed. The same distance may be covered in 5 hours if the cycling speed is increased by 8 km per hour. Find the distance traveled. Again, a question of proportionality. See that cyclist is traveling a constant distance. Time is given to me. First time, right, is given to me as 6 hours, and then the time later on the time taken is 5 hours. So time ratio is 6:5 here, right? Time ratio is 6:5 here. First it's 6 hours, then it's 5 hours. So time ratio is 6:5. The speed ratio must be inverse of each other, right? Because as we have studied earlier, if distance is kept constant, speed and time will be inversely proportional to each other. The time ratio is 6:5, speed ratio is 5:6. Right. So now you see that The difference in the speed is 1 here. I want this difference to be equal to 8 kilometer per hour. So earlier the speed is 40 kilometer per hour, and here the speed would be 48 kilometer per hour, right? So at a speed of 40 kilometer per hour, this person is taking total 6 hours. So distance, as we know, is speed into time. Speed is 40, time is 6. Total distance travel will be 240 kilometer. Option B is the correct answer. Thank you so much for watching this video, guys. We have covered 15 questions till now. Rest of the question will be discussed in the next part of the video. In the next video, we'll start with question number 16. Thank you so much for watching the video. Please revise all these concepts. Proportionality is something which is very important in TSD, which will be useful in most of the question of time, speed, and distance. Thank you.